Hello. This video series is about finding an incomplete public project and finishing it. I see one without any post-processing image. I will check first whether this is an incomplete one or not. Yes, it is incomplete. Now I will copy this project and continue. There will be some jumps in the video such as the previous one because I don't want to waste your time on doing some simple yet time-consuming operations. First thing I noticed is that the CAD model has unnecessary details. A recommendation: never leave those marks, text, etc. in your CAD model, neither CFD nor FEA, because it will only increase the number of elements in the mesh or the number of nodes, and or it will cause mesh failures. So you can use SimScale's CAD mode to clean those details and imprint the model. Imprinting is necessary here. It's not a must, but it is actually it's a must. You should imprint the assemblies always. Okay, this is the way to clean the text. I will just do one as an example, then pause this video. And assuming then that all the cleaning is completed, you need to imprint the model here, imprint function. Just apply, and once the imprint is finished, you can just press finish to export the model into Workbench again. My model is in Workbench right now. I see the existing simulation setup of the previous user, but it is not complete, and I really don't know what kind of boundary conditions or the loads he was planning to apply here. I will create my own simulation. It will be again a static simulation. However, I'm planning to add some load and turn this into a nonlinear static simulation. The CAD model, now I can change with my new cleaned one. Automatically the contacts are captured. Let's check whether the contacts make sense or not. So there is one contact, bounded contact between tongue and washer. That is correct. However, here I want to apply bolt preload. So this face, cylindrical face, I'm planning to use in bolt preload assignment. So I will remove it from the bounded contacts. I will clean these contacts here and create a new one. I want a new contact between the tongue and the tongue ball. Let's select the first one. Then the slave assignment should be the opposite, the Towbar. My third contact is between washer and nut. Now, to be able to perform a successful simulation, I need to fully constrain, I need to add enough constraints in this model. I'm planning to add a bolt preload boundary condition here. Between Towbar and tongue, there is contact. Between the washer and tongue, there is contact. And between washer and nut, there is contact. However, there is no contact between the nut and the bolt. This is what I need to do here. Let's hide the bolt, create a new bonded contact, select the face, and invert visibility. No, that just assigned. Invert visibility, and now a contact to the nut. Alright, so the contacts are completed. Let's check the boundary materials. I don't know which material this thing is made up of, but I will use steel for every part now. Alright, Again, here I'm using linear elastic material. Of course, depending on the simulation results, you might prefer elastoplastic model if the stress values are above the yield. Now the boundary conditions. I checked previously there was a code here. I checked that and noticed that this is a kind of mechanism attached behind a vehicle to be able to pull another vehicle. So here is the fixed support. There will be here another mechanism which applies a load in probably positive x direction. Normally, of course, that chain mechanism will add more load on this surface than on the back side. However, here we don't have that boundary condition. So I will just simplify the load to be applied evenly on the selected surface. Now, this is a nonlinear simulation. It is recommended to ramp up the load. My load is, I assume it will be 25 kilonewton. I will ramp up the load with respect to time, which is arbitrary time. So with this graph icon, let's make the x to be time value. Again, this is arbitrary time, so I'm simulating from 0 to 1. From time 0 until the end of the simulation, the y and the z loads are 0. However, from time 0, the load is 0, but until the end, my load will be increased to 25 kilonewtons. Alright. Then finally, bolt preload boundary condition. Again, I do not know how much preload is going to be applied here, but I will just randomly give a number 5,000 newtons. Application between exactly the toe ball and the tongue. Now the meshing. I will just use a very coarse mesh and first order. Of course, it is recommended to increase the fineness or add manual refinements to capture those rounds, and also using second order. That is a recommendation for more accurate simulation. Then you can simply click simulation run. It will first generate mesh and then start the simulation. Simulation has just finished. Let's check the results. So initially what you see is the last state. Let's come back to the initial state. In the initial state, the model is loaded with preload. That's why you see this stress concentration. And starting by the first time step, I will just switch to megapascal values. Okay, you can now follow that in each time step the stress value increases because I ramped up the load. So in the last time step we will see the maximum loading or maximum stress. That's all. Hope you like it. See you next time.